Welcome. Today's presentation will be focused on migrating your monolithic software architecture to a distributed microservice environment. This is a process that is being undertaken by more and more organizations these days, and hopefully we will be able to provide you with some guidance and tips on how you can successfully plan and execute these migrations. First off, introductions. My name is Andrew. I am a solutions engineer at Lightstep. Prior to this, I spent time at New Relic and other software companies and have over the years helped companies on their observability journeys in both monolithic as well as distributed software architectures. For today's presentation, we will be going through an example migration process. We will discuss the overall strategy for the migration, how to use observability to de-risk the move, and also discuss what modern observability looks like in this new microservice world. Let's assume that we are starting off with a monolithic e-commerce application illustrated here. You may have done a lift and shift migration of that service from bare metal or VMs into Kubernetes, but the service itself is still monolithic. It still contains code functionality for everything from handling logins, authentications, all the way to shopping carts and payment systems. So if one of these functional areas suddenly sees an increase in traffic, such as many more users logging in, there is no way to scale up just that functionality to handle the increased volume. You would have to scale up the entire application instead. This would not be an efficient usage of your Kubernetes infrastructure resources. Usually, when you're starting out, monolithic architectures can have some benefits in improving development velocity because all code is in one place. Eventually, this starts breaking down as you introduce more functionality and your application becomes more complex. Monolithic architectures have a hard time adapting to increased traffic volumes or different traffic patterns. As you scale your engineering teams up, it becomes more difficult and slower organizationally for all these engineers to be working on the same code base. Because of these reasons, many companies today are looking to decompose their existing monoliths into distributed microservices. The goal of today's exercise is to split out payments into their own microservice and to integrate in a new third-party payment endpoint. We want to accomplish this with minimal disruption to the overall business. So this diagram illustrates the end state desired. In this example, the payment functionality has been broken apart into its own microservice with no downtime and no interruption of service for the end user. A new third-party payment processor has also been integrated. The practical business result is that no revenue is lost because of the migration. As you can see, some of the third-party calls are shared by the two services. Cart storage and authentication are still hitting the same providers. This is not a problem because we can simply use a shared library for calling these endpoints. But because the payment calls themselves are now split into a separate service, it can be horizontally scaled independent of the main service, and development of the new payment service is now decoupled from the main service, helping increase development velocities of both. So let's talk through the migration process. We know that we want to separate the payment functionality from the main monolith. We want the new service to be horizontally scalable, integrate a new third-party processor, and simply operate asynchronously from the rest of the stack. In order to achieve this, let's talk through some of our considerations and tips. First off, I would recommend defining must-haves up front and start thinking about appropriate SLOs. We don't want to approach this migration blindly, and there is no way to know whether we've achieved success unless we have a way of measuring it. So some examples of must-have based on what we've already discussed are things like scalability, more reliability, integrated to the new third party, and zero downtime. Zero downtime means that we are not affecting any upstream services during migration, and we are not affecting any end users. So let's start with SLOs, or service level objectives. Sometimes these are referred to SLAs or SLIs, but they all essentially measure the same things. Everyone has opinions on what should be measured, but we have some tips and suggestions based on our experiences. Upstream SLOs define a performance and reliability contract with the upstream services that rely on you. This is relatively straightforward. Downstream SLOs define expectations for services that you rely on. Oftentimes, these will be services that you have no control over but are dependent upon for achieving your own SLOs. Defining this SLO protects your team from blame, allowing you to clearly differentiate if a performance issue is caused by your own service or some downstream service. Defining executive level SLOs are also important. What does your business leadership care about? These measures are usually tied to the business value provided by your service and may or may not be exactly the same as the SLOs that you define at the service level. Ultimately, your application is there to serve your customers, so it's important that your internal service SLOs conform to your business objectives. You can use observability systems that leverage distributed tracing to help measure and define these goals. Distributed tracing is useful here because it provides the context necessary to measure these objectives. So here's an example of how you might go about defining your SLOs. The business critical SLO here is that when an end user clicks the pay button, the payment executes without errors and quickly. Your own payment service is directly called by the business critical operation. It might also be called by other services. This is where you define your services SLOs in terms of response times, uptimes, and error rates. Thirdly, your services will be calling downstream providers, such as the payment processor, authentication processor, or your own card storage. It is useful to define your services' expectations of performance and reliability for these downstream services. So some examples of SLAs or SLOs would be things like, alert when a third-party payment service has an error rate greater than 0.1%, or alert when the payment endpoint has a P99 response time of greater than 5 seconds. These are, just examples. So next, let's talk about operations. These are all areas you might want to consider before starting your migration. These include things like containerization, configuration management, CI/CD, etc. Once you start creating one service, you will want to create more, and having a well-established, repeatable, and reliable process for standing up containers and configurations will help speed this process along with confidence. Also, you will want to do some rough cost estimations for some of the components in your call stack. For example, you don't want to find out 6 months down the road that you can no longer call your third-party payment service because they are too expensive at your scale. If you will want to know these types of things ahead of time because it will affect your architectural decisions. Another thing that might be obvious is that you should stick with the languages that are familiar unless there's a very good reason not to do so. This helps standardize the knowledge base set across your organization. We've seen companies that are pretty open to allowing their different teams to do pretty much whatever they want. And although this will probably make the teams happy in the short term, it becomes more difficult to maintain long term. Teams change, people leave, someone else will eventually own that service, and if they are not familiar with the language, it will become that much more difficult to maintain. One other question that is often asked is when one should use serverless functions like Lambda. This depends on how familiar your team is with the technology and how complex your business logic is, especially if the logic is stateful. The ephemeral nature of serverless functions makes it difficult to maintain state in these very short-lived functions. And if your developers are not experienced with using serverless functions, it also becomes a steeper learning curve. One other thing to consider is the typical response time of your calls. If they are greater than about 30 seconds, I would not recommend using serverless functions because they tend to have timeouts around the 30-second range, which can cause you all sorts of problems. These types of scenarios are probably better served using short-lived containers like Fargate or a microservice. So next up, let's talk about API contracts. How is this new service going to interact with the outside world? The easiest thing is if that contract doesn't change. We know that that's probably not realistic because when you do something like breaking the payment service out of your monolith, you may also want to change the API interaction from, say, an XML endpoint to a REST one. Providing the API contract early allows teams that depend on your service to start their dependency change sooner as well, and not have to wait until you finished your development. If you have time, we would recommend using something like Swagger to enforce your API stability. There are also tools that help integrate Swagger with your code base, so your APIs live right next to your code, your API definitions. This helps enforce API stability as well as letting everyone know the status of your API definitions as you're building them out. I would also recommend understanding and diagramming the existing behaviors within your monolith so you can understand existing behavior patterns and current performance limitations. You can then build these into your must-have list for your new microservice. That way, you can ensure that your new service behaves and performs as well as your existing, at least as well as your existing monolithic code. This is something where observability systems leveraging tracing can really help because it will show you these code paths in your existing monolith as well as the same behaviors in your new microservice. Without tracing, this is very difficult to do because looking through log files and metrics won't be able to tell you if certain methods and components are being called and in what circumstances. So let's talk about the data flow. Thinking about data models. This new third-party payment processor that we are integrating it with. What is the data model and business logic of this service? Will we need to create any data transformation for this new service? What are the external infrastructure components that we will need to run it? Is this something that we are familiar with and know how to operate, or is this something new? It may be worthwhile to take a sprint to understand these behaviors. Ultimately, it's about de-risking the migration. So one tip is to brainstorm these risks early. For example, if you are planning on using a new database, what is the infrastructure required for running it? What are the throughput capabilities? What are its performance profiles? Spending time benchmarking and analyzing this new system, as well as your current system, will help de-risk the move by having a better understanding of the capabilities of the new components so you can design for its strengths and limitations. This will also allow you to create management plans and playbooks for working with these new systems. Another tip is to plan how your migration to the new service will happen, as well as planning for that plan to fail. Will you migrate a percentage of your traffic at a time, one endpoint at a time, all at once? What constitutes done for your migration? What happens if things fail? How will you roll back to your previous state? How will you roll back during each state of your migration? How will you completely roll back to your monolith if the new service doesn't work for whatever reason? All of these considerations will help contribute to the zero downtime goal for your migration. So those were all the things I wanted to discuss regarding migrating your code from a monolith to a microservice. Next, we want to discuss what sorts of effects a microservice architecture has on your systems. As well as the number of services grow, the complexity of your system grows. Your team may only have control over one or a few services, but your own SLOs that you are responsible for are affected by an ever-growing list of teams and services downstream from you. These are services and components that you have no control over and may not even know about. How do you understand where the responsibility falls in this situation? The answer is that this is more of an observability challenge. In a microservice migration, you are introducing more complexity into your system. You are growing from a single monolith where it's relatively easy to reason about its behavior patterns to more and more services that interact with each other but are distributed and decoupled. This also introduces more points of failure in the system because you are making more and more inter-service network calls as well as spreading these calls out to external services. Say your monolith is calling a MySQL database. Because it's only one service calling the database, it's relatively easy to understand the traffic patterns. All the calls are coming from this one service. If you now have 10 different services, some calling the database and others not, it will become more difficult to understand the traffic to that DB and where the load and bottlenecks are coming from, since you are now coming from multiple services, each with their own behavior patterns. Let's take a look at an example from our system. What you see here is a service diagram from one of Lightstep's actual customers. Lightstep is an observability tool that ingests distributed tracing data along with other data sources. Using this distributed tracing data, we dynamically construct these service dependency views of your systems. So looking here, your team may own, say, the service on the top left. But as you can see, that service is dependent on a large number of downstream services to complete its work. Now, this is a somewhat extreme example of service complexity, but this is exactly the type of thing that happens when you start going down the path of microservices. System complexity, depth, and service interactions, all of these things increase. Here's another example. The service with the blue dot is the service you own. But as you can see, that service has multiple upstreams as well as downstream dependencies. And as the complexity grows, we oftentimes see this type of behavior in the bottom, where the depth of service calls also grows. This growth eventually gets to a point where it is no longer possible for a human to understand the transactional logic going on. You will have to start relying on observability systems to help generate these types of dependency maps. Even then, it will become more and more difficult to understand your individual API call stack just by looking at this map. Using an observability tool with distributed tracing can help. A lot of people think that this type of observability is useful once you have already migrated to a microservice architecture. We think that it is important to start with your monolith because it will help de-risk your migration in several areas. The first I want to discuss is around code complexity. Monitoring and tracing your monolith will help you identify and understand which code paths will need to migrate to the microservice. Using tracing, we can see what these code paths actually are. Once the code is migrated, we can use tracing to see if the deprecated code paths in the monolith are actually deprecated and no longer exercised. Without this visibility, you could not have the confidence to remove this old code from your monolith, leaving behind zombie functionality because you cannot be sure that it's no longer needed. Thirdly, visibility during deployments will help you ensure that we do not introduce unexpected regressions to these old code paths. De-risking for performance regressions. Your observability tool will help identify performance regressions in your monolith and your new microservice by collecting the golden signals of response times, error rates, and throughput. This allows you to ensure proper performance of your services, giving you confidence that you are fulfilling your API contract to your upstream services. It also allows you to collect the same telemetry for your downstream services and external third-party services, thereby allowing you to hold them accountable for their service contracts. Finally, de-risking for external dependencies. Observability systems will help your developers to see the performance of their new services as they are being built. It will provide them with real-time performance information on their own services, as well as external dependencies that they are calling. This allows the developers to verify that their external services are actually responding, as well as collect the performance metrics for these services to understand whether they are behaving as expected. Then, wrapping these new service calls into easily debuggable and understandable SLOs will give everyone a clear picture as to the state of your systems before migration as well as after. After all, you do not want your new service to perform worse than your monolith. Otherwise, what's the point of migrating? Well, that's all I wanted to touch on regarding your monolith to microservice migration. A quick plug here. Lightstep is an observability platform built to handle these types of de-risking tasks. We have specific workflows for analyzing deployments, regression, and dynamic service and operation dependencies, and can provide the visibility necessary to achieve a successful microservice migration. We have deep experience in helping our customers with observability throughout their monolithic decomposition journey. So please feel free to reach out to us. My email is at the top of this presentation, and we would be happy to help. Thank you.